I'm very glad to be here to talk about this recommendation. Recommendation has become popular due to the e-commerce. Recommendation can not only be used in product recommendation for e-commerce, but it also has many other applications. For example, friends recommendation in social network. You can also use it for treatment recommendation in medicine, to do answer recommendation in QA or dialogue system. And then even for job application, you can find the candidate from this job application pool for each job. So in the era of big data, when we talk about recommendation, we are talking about personalized recommendation. The goal of personalized recommendation is to tailor the recommendation based on the interest of the individual. This is in contrast to the recommendation in the past based on aggregated information. For example, we often look at what is the best-selling book, the top-end selling book, movie, or music. Those recommendations are based on aggregated information. It's saying that most people like this book or movie. However, what most people like is not necessarily what you like. So that's the reason we want to do personalized recommendation. Even in medicine, for example, if a person has cancer, he needs this chemotherapy. Usually, the doctor will recommend the most effective drug, the one which will cure the highest percentage of people. For example, if one drug A can cure 50% of the people, and that drug B will cure only 10% of the people, then the doctor will always first recommend drug A. If it doesn't work, then we will try drug B. But for that particular patient, maybe drug B is really the right medicine. So that is what we talk about personalized recommendation. There are two different techniques to do personalized recommendation. One is what we call collaborative filtering. It is basically trying to identify people similar to you are, and then looking at what they like to recommend to you. So basically, we want users to do some rating on the movie, and then we find other people who do similar rating on that set of movie, and then we identify those people are the like-minded user as you are. So we'll use them as a base to do recommendation. The other approach is content-based recommendation. For example, if you have watched some action movie, then we assume that you like action movies, so we will recommend some other action movie. So the two approach, the collaborative filtering is basically user-centered. We look at similar users. And the content-based recommendation is item-centered. You look at similar items you have previously purchased or liked. But either of approach, we will have what we call a co-star problem. For example, if you look at user ratings, right? This is from the Amazon movie database. You can see most of the people, right? They only rate a very few number of movies, like 5 to 7. Very few people rate a large number of movies, like more than 30 or 40. But if you don't rate many movies, then it's very hard to find other like-minded people as you are. So that is what we call a co-star problem. The other problem is the representation problem of user or item. For example, if we look at if you want to do recommendation on movie, so there may be 10,000 movies, but so if you use each movie as a dimension and use the user rating as the feature value, then you will see that most of the attribute value is 0, since the user only will provide rating on a few number of movie. So this kind of representation is not very efficient. So we really want to look for a low dimension representation. So we also have a lot of opportunity in this big data era, because in the big data era, there is abundance of data sources can help discover various relationships between user and item to help us address the cold start problem. But the challenge is that the data are often heterogeneous. That is to say that they may be of different type. Some of them are text data, some of them are image data. And then there are different type of relationship between the entity, which can complicate the representation learning. However, with the advance of learning technique like deep and broad learning, it will provide a better user and item representation. I think everyone is familiar with deep learning, maybe less familiar with broad learning. But in addition to depth, we also need breadth through fusion of multiple heterogeneous data sources. For example, when we talk about recommendation, we want to do collaborative filtering. We certainly can use the rating information the user provide on the product, right? So we can apply deep learning to this kind of rating information. But there are also many different types of information we may be able to leverage. For example, a user not necessarily just provide a rating. He may provide a product review, which give more detailed information on what he likes and what he does not like. And then there may be a knowledge graph describe the relationship between the items. For example, if we are talking about movie, then different movie may be related because they have the same actor or the same director. And then if we have social network information, we know who are the friends of this person. Then we maybe also get idea from what his friend like. So if we can fuse all those information together, although they are very different type of information, right? Rating information is just a number. Product review is really is text information, right? Knowledge graph, right, is relationship between the entities, right? It's a graph, right? Social network also is a network graph type of relationship. So this is what we refer to as broad learning. So in the era of big data, we actually have all kinds of data available. The big data doesn't mean that we have a very big database with many attributes. Actually, there are all types of information. So in order to do a better learning, we need to be able to first identify and acquire the relevant and useful data sources, and then devise a model to fuse the information from this heterogeneous data source together. And then for each data source, we can mine the information from that data source deeply based on the need of the overall model. So when we want to do recommendation, right? First type of information we can use certainly is the rating information, which user saying that which movie he likes, right? And then there are many other type of information we can use. For example, like this product information, which provides information between different products that can be represented in the knowledge graph. And then we can also use user profile information, and then user social relationship, the friends of the user, right? And then we can also use product review or even product description. And then we can also use cross-site information. And then there can be also temporal information, because when the user's purchase histories, right, also can indicate the changing behavior of a user. And then we can also have context information, right? For example, if a user in a supermarket, he can buy multiple things, and there are correlation between those items. So that is what we refer to as a context information. So we first look at structure information. How do we explore structure information? The user purchase history can actually represent it as a bipartite graph. So in a bipartite graph, for example, a person like Tom, right? So you will point to the product he has purchased. In this particular case, that Tom has purchased 2 books. One is a Python book, the other is a deep learning book. Bob, he has purchased a Python book and then a laptop. So we can maintain such a bipartite graph, which will record the user and item relationship. And then from there, we can use it to help us to do recommendation. For example, in this particular case, we can see that Tom and Bob, have both purchased this Python book. So it means that they may be very similar. So then we can use the other things that which Tom purchased and then recommend to Bob. So Tom purchased another deep learning book, right? So this is something we can recommend to Bob. Okay. And then Bob has purchased a laptop, so we can recommend a laptop to Tom, since they are similar, right? But in order for this to work, we need to have a lot of edges, right? Otherwise, that we will not be able to find a path between a person and an item. So this is what we talked about before as the co-star problem. Okay. So in here, we first want to explore the rating information, the user rating on movie. This is the standard bipartite graph information. But on top of that, for example, if we can explore that, for example, these 2 movies are having the same director, or they are movie type. For example, this is action, this is science fiction. If we can and use this type of information, knowledge graph information to relate the different movie, okay, then we get some connection between the movie. And then if we explore the social relationship between the user, then again, we are getting connection between the user. And then we can also use attribute information to connect the user. So now we are building up more edges on the graph that will help us to do recommendation. Okay, so starting from this rating information, so we will add this knowledge graph information on product, and then we will add this user profile information to connect user, and then also this user social network. Okay, so this particular graph on the right, right, we can refer to it as a heterogeneous information network. Because heterogeneous in the sense that they are different type of entity. For example, you have person, you have movie, you have the movie type, you have the director or actor, right? And then you also can have a different attribute. Okay, so this heterogeneous network, right, can actually be represented by the following schema. Okay, schema is an abstract representation of the network entity. So in here we can see that we have user. User can provide rating to the movie. The movie has director, and movie also have different movie type, and the movie can also have actor. And the user have different user group, and user can have friendship relationship. So from this schema, right, we can define a path between the different entity type, and then this is really a relationship between the entity type, and it have a very specific semantic on it. So let's take a closer look. For example, if we go back to this schema, right? So we can see that the meta path UGU means that these 2 users belong to the same group. So this is a specific type of relationship. UMU means that user, movie, user means that just 2 users rate the movie similarly. Okay, so that is the traditional or bipartite graph connection, right? But now we allow more flexible way for the 2 users to be connected. For example, UMDMU means user, movie, director, movie, user. So what it means that the user, they like movie from the same director, but it's not the same movie. That also is a kind of relationship. Certainly it's weaker than user liking the same movie, but still this is a relationship. It can be also the 2 users like this movie from the same actor or the same type. So if we can capture all those different type of relationship between the user, okay, so the relation certainly is much stronger than the other relation. We can learn it from the data. From here, then we can see that when we more explicitly explore all kinds of different relationships, the different structure, then we'll be able to do much better than the traditional collaborative filtering. So when we predict the user's rating on the movie, we can see that the error will be much smaller. Okay, and there's another approach is that we're trying to find a representation for each of the users. For example, if this is a user social network, right? So we can try to find what we call the embedding. It's a low dimensional representation. So people which are connected, for example, these two persons are connected, then they will be close to each other. This is another cluster of people. Okay, they will be close to each other. Okay. So although this is what we have is a heterogeneous network, we have different type of a node here, which is not a homogeneous network like we see before, right? We have not just user, we have movie, we have actors, right? But we can define a meta path. For example, UMU, then the two users is connected if they like the same movie, right? So for each meta path, it becomes a homogeneous network between the user, and then we can find the embedding, and then we can combine all the embedding from this different network, right, together to get user representation. From this node, we can get a much better result compared with this collaborative filtering or the method we talked before. Okay. Okay. The next we're going to look at cross-domain information. For example, many e-commerce sites, they only have transaction information. For example, you look at Amazon, they only have your purchasing history. So it knows that you have buy camera, this kind of thing. But he doesn't know that who is your friend, okay, who has similar thinking as you are. But if we can combine this e-commerce site with a crowdsourced review site, right? If we can match the people and the product, right? Then from this product review sites, right? We can find out which person follow your review, okay, or like your review. So they are like-minded people from you. That will increase the way we can do recommendations. So the e-commerce site only have this bipartite graph, customer and product, which product you have purchased, right? But then we have the review site, right? Review site also have which person has like your review, that follow your review. So if we can match the two sides, right, then we will be able to do better, right? For example, in here, for example, we can have a meta path, which is saying that, okay, so for this customer, he mapped to the user in this review site, and this review site has another user who is similar to this person. And then if we map it back here, then we can find some other like-minded customer. So by doing this, that again, that we'll be able to improve the accuracy of the prediction. Okay. The next thing we're going to look at is context information. Previously, we talked about this user-item relationship, but in many places, for example, if you go to Costco, right, you're going to buy a lot of things. You are not just purchasing one thing, okay? So we call this a basket. So for every time you go to shopping, you buy a lot of things. So the basket contains many items, right? So and there is a relationship between those items, and also there's a relationship between basket. So we're going to explore this co-purchasing pattern. That is what we refer to as the context. Okay. So if you look at the persons, right? For example, person A, that is his basket. So he actually contains, for example, bread, cereal, and yogurt. So all those things actually related to breakfast. And then he also buys soap and detergent. That actually is cleaning product, right? So if you look at this particular basket, right, you actually include two intent there. one is a breakfast related thing, the other is cleaning related thing. And we look at another person, okay, so he bought milk and waffle. So again, this is a breakfast type of thing. But on the other hand, he also buys something like banana, apple, strawberry. So those are fruit, right? So you can see that, okay? So a basket can include multiple intent. Certainly different people, they may have partial overlap, right? For example, these two people, they have overlap on breakfast, but they also have different interests, right? So we want to find this kind of correlation to help us do the prediction. So if we can predict the intent, then we'll be able to better predict that what is actually in the basket. So that will be able to improve the accuracy of the prediction. That is compared with traditional collaborative filtering. We do not really take the context of the basket into consideration. Then their accuracy will be lower. Okay. So the next type of information we can consider is text information. Previously, we talked about rating information. Rating information, because it is a single number, so it's very easy to handle. We can say if two persons rated a product with rating 5, then we say they are similar because they all like this product, right? But actually, not only we have the rating information, we also have the review information. Review information actually give you more detail, give you the reason why a particular person liked the product. Two persons can like the product, give them the same rating for very different reasons. For example, if a person went to a restaurant, he give it a 4, right? Maybe it's because he liked the atmosphere. But the other person go there, maybe he liked the service. So it can be so in that sense that although they give the restaurant the same rating, but it's for very different reason. If the reason is different, actually that two persons are not necessarily that similar. So we really want to find persons who are similar in the sense that they like the restaurant for the same reason. Before, analyzing those reviews is kind of challenging, but now with the deep learning techniques, right, we can easily process those reviews, and then we get the basic essence that why a person liked a particular item. Okay, so if we can use the review, the question is that how do we really use the review? There are two perspectives on the review. From the user's perspective, a user may have written many reviews to different products, right? But if a user really care about the atmosphere of the restaurant, then you can see that a lot of his reviews will all talk about this topic. So we can aggregate all the review from a particular person, okay, to use that to represent the characteristic of the user. Similar, for example, for a restaurant, we get review from many different people, right? But however, if a restaurant has a service problem, right? People don't like the service, then that will reflect it in many of the review. So we can also aggregate all the review to that restaurant together, right? So that will also reflect the restaurant's characteristic. Okay, so basically we can take all the review from user, right, and all the review on the restaurant, and then we can apply this deep learning on those tags, right, and then we can get the user and restaurant representation. Okay, and then so we can use the text to get user and this restaurant representation. And then also at the very beginning, we talk about we can use various structure information to get their representation. So we can combine the two together. Okay, so by doing that, then again, that you can see that we can substantially improve the accuracy of the prediction. So finally, we consider temporal pattern. So previously, when we talk about a user-item relationship, that we try to represent as a bipartite graph, okay? But the shortcoming of represented as a bipartite graph, that then we lose the temporal information because we only know that this user has purchased this or like this three product, but we do not know how, from a temporal viewpoint, what happened first. So if you view it as a sequence, right? For example, a person at time 1, he buy a swimming suit, and time 3, he buy a shoe, and then time 5, he buy a goggle, and then time 8, he buy a bottle opener. Then we can see the behavior pattern. Maybe there's a changing, right? So by using this temporal information, we may be able to better prediction, because usually the more recent purchase is more relevant to do the prediction of the next item, right? Okay, but if we just focus on a single sequence from a user, right? We capture the trend, but on the other hand, we're ignoring other similar minded users' purchase behaviors, right? That can also play a role on what is purchased, because it's not just a timing trend, it can also be affected by his friend, right? So we should try to capture both of them, okay? Because you can see that his purchase behavior, for example, his friend, he buying a son, maybe it's affected by his friend buying a shoe, right? And he's buying a wine may affect his friend buying a bottle openers, right? So this is the traditional collaborative filtering information. So we want to capture both the temporal and the other structured type of information. So that certainly is challenging, because if we just consider a sequence, that is easier, because in deep learning, we can easily handle a sequence. But if we also want to consider this other user sequence, then it's become a more challenging problem, because then we're really having to capture the changing of the bipartite graph over time. Okay, but if we can do that, then you can see that we can do a much better prediction, okay, compared with just doing with a sequence. Okay, so in summary, that today we talk about recommendation. Recommendation have wide applicability beyond e-commerce. For effective recommendation, we need to fuse heterogeneous source of information, and then learning need both breadth and depth. Okay, so we need to apply both deep learning and broad learning together. And some future challenge, for example, or this recommendation needs to improve on interpretability. Okay, in e-commerce application, interpretability is not that important, because if you go into like a Amazon or Netflix, right? They have so many transactions per second, right? So the recommendation has to be very fast. So no one can, there's no human intervention to really understand the recommendation. People just looking at the hit rates, right? How many of the recommendation get selected by the user? If they can improve the hit rate, then actually improve the company's revenue. So that represent, so that means goodness. But if we want to apply recommendation to the medical domain, then that is different, because if we are going to recommend treatment to a patient, that rate is not that high. Actually, there's an intermediary rate. That is the doctor. The recommendation goes to the doctor first, right? Doctor has to be comfortable with the recommendation before he will suggest it to the patient. So in that sense, that we have to provide some interpretability. Another thing is fairness, right? So we have to make sure that we are doing in a fair recommendation. For example, or if you have a position open and then there are many applicants, we can use recommendation engine to recommend the appropriate candidate for each position. But for that kind of application, that fairness is very important. Right? So this is the end of my talk. Thank you.
Thank you very much, Professor Yi, for your very interesting talk and very informative as well. May I ask questions from the audience, please? Well, while people might be thinking of questions, let me ask a very basic one to kick the ball, to start the rolling of the ball. There seems combining the mental knowledge with the kind of data analytics using the kind of relationship diagrams. It is a very interesting and very exciting as well. But the question is, can we learn this relationship, mental model, whatever you call it, from data, or you have to use the human knowledge already we have to build the model first?
Okay, so this knowledge, for example, for a movie, who is the actor, who is the director, this kind of information is readily available. Okay? But if you only look at the transaction database, right, then you don't get that piece of information. So you do not know why a particular person, after, for example, in a Netflix environment, you watch a movie and then watch another movie, right? So we need to gather all the information together that will help us to make the right prediction. Because if you can see the trend is that, all those movies are action movies. If you have that piece of information, then it's easier for you to, or more likely for you to recommend the item which we are interested. So we need to be able to collect all those type of information. The more information we have, the more likely we are going to make a good recommendation. For example, another piece of information you can have, for example, if you really know, for example, Netflix doesn't have a social network, but if you can connect it with, for example, from Facebook to know who his friends is, or you can look at the chat he's participating in, right? Then you will be able to know that what his friends thinking, right? Then you will be able to do better recommendations, right? So sometimes people want to log in through Facebook, right? Then they get your friends' information, right? Then because friends' information also is powerful, right? So that's what we are trying to utilize all the relevant information. The more relevant information you can gather, you will be able to do better. I mean, there's no magic, right? Big data, you have all kinds of information. That's the reason that why Google is so strong, right? When they are placing advertisements, right? They can charge you premium price, right? Because they know the user much better than you are, than any other vendors, right? Because in Google, they have this search engines, right? So they know what you are searching. So that is useful information, right? If you use Google Mail, he also knows something more about you, right? If you're using the Google map, he even know where you are, right? So for example, if I go to London, I want to search restaurant, then if they know I'm in London, they definitely will not recommend me a restaurant in Chicago. I'm in London. If I know exactly my locations, right, through the Google map, he will recommend me restaurant within the walking distance, right? So that is why this using all this kind of information together is powerful.
Yes. Thank you. Thank you very much for the answer. Any questions from the audience now?
Yeah, this is Jerry. Dr. Philip Yu, very good question, very good talk. I have a simple question because according to what you say, it sounds like in the future, the recommendation need a more kind of a learning recommendation based on personalized, based on location, based on many factors, right? According to existing research, most recommendation is kind of formula or rule-based, or maybe it's a ranking index-based. So I'm just wondering, is it fixed, right? According to what you say, if I if I travel to a different place, I may have a lot of things I need to recommend, like a hotel, food, everything, right? Travel place, whatever. So it's more like a personalized or center-oriented location recommendation. That's a one kind. But depends on what kind of application, depends on what the needs. Just like a previous talk, similar. You have all kind of a diversified situation. So the conventional way to do recommendation maybe is not good enough for future needs. What do you think?
Yeah, so the future is to be personalized, is to specifically recommend something based on the particular person in that particular moment in time, based on his location, based on the time of day, this kind of thing. Because now we're in the era of big data, so we have a lot of data, right? So we can understand a person very well. If you think about it, before this the e-commerce big data eras, right? Where people always based on aggregate statistics. So we always talk about what is the, if you look at the music, they always talk about what are the top 10 music sold the last week, right? They have this ranking, right? Movie, you also have the ranking in the last week. What is the top 10 box office movies, right? Book, we also talk about New York Times best-selling book, because those are all based on aggregate statistics. But aggregate statistics is not necessarily what everyone wants. For a lot of people, they don't care about the best-selling book, right? Or the best box office movie. They just want to see a particular type of book or particular type of movie. So if you look at Netflix, they are doing exactly that, right? So they are based on what you have watched previously, right? So then they make that recommendation. So it's very tailored to that particular person. They don't tell you that, oh, this is our top 10 movies, right? That is not necessarily very meaningful to a lot of people. But we can do it
other
today because
questions?
we have all the data. This is the key. To do personalized recommendation, you must have a lot of data. If you don't have data, you cannot do this kind of thing.
Yeah. Any other questions from the audience? Well, I have one in my mind. In your summary, you mentioned the future challenges about fairness. Fairness is very important for the ethical issue of the machine learning. But there are more things than that. For example, if someone pays a lot of money for Google to recommend their product, it is not the best interest for the people to, as the consumer. So how could these kind of things be dealt with in the AI application to get people to trust to say the recommendation is the good thing?
So I think though, I think in a lot of those cases, they separate what is a paid advertisement, right? I think they specifically said, but certainly they manipulate the, in certain case, they may manipulate the ranking. But I think in the longer run, it really hurts their reputation because they are not recommending, not necessarily what really is the best for the customer. They are recommending who pays that, right? That will sooner or later get them into trouble. So they really have to differentiate that. Okay, but for e-commerce, this kind of thing also is very different from some other area. For example, from in a medicine areas, right? Because if you recommend treatment, you cannot recommend the drug, the pharmaceutical pay you a lot of money to, or you go to their conference or things like that, pay you some vacation and ask you to recommend. If you do this kind of things, then that really is a serious ethical issue because it involves people's lives, right? This movie recommendation is a little bit different. Okay.
Yeah, the situation if someone paid for the recommendation is clearly there is an issue. However, the data might be biased. Therefore, the recommendation is biased towards certain providers of the product or whichever. That is the difficult spot. And how can we test it? How can we validate you are not biased?
Yeah, that is definitely a hot research topics, right? So we have to be mindful that because we are based on the data, sometimes it's not. I mean, so there are two situations. One is intentional bias, right? That is a different type of thing. But what we are talking about is the unintentional bias, because the data collected is because your customer, for example, if you if you have more teenage customers, right, then your recommendation is biased by those teenagers, because you have more of those customers. So then from an older customer coming, right, the older age customer, then the recommendation may be biased because of they have so many teenagers, right, young customers, right? So we have to be able to make sure that we don't have that kind of situation. And that kind of situation is an addressable problem.
Yes, yes. Typically, I saw the application area in job application, the recommendation for employment.
Yeah, that is a very sensitive area. Okay, that is very sensitive, because if you recommend a wrong movie, I mean, that is because of more male people watching the movie. That is a different scenario. Job is kind of thing is very sensitive.
By the way, there's a question in the chat box you want to reflect to?
Yes, yes.
Okay.
Okay. There is a chat board, a question from Peter Strenberg. He said, thank you for an interesting talk. Could you please give some suggestions for fairness? For example, in a recruitment process. Yes, it's what we've been talking about. It seems my audio is lagging. Okay, that's the question.
Yeah, so usually you have those sensitive attributes, right? So you want to make sure that it is no bias relative to sensitive attribute.
Good.